We are in Algebra 1. We are, oh, there's my phone is going to randomly decide to update. We are on Thursday, November 8th. Yes, we are going to write the date up here. November 8th. What is going on with my trackpad? It is getting warmed up. There it goes. Thursday, November 8th, so 11/8. Algebra 1, we are talking about our new unit, testing and plotting inequalities. So everything in this unit is inequality. So let's talk about an inequality. What is an inequality? Let's dissect that word. This in means not. So underline this in, it means not. And then you can read the rest of the word equal. Inequality literally means not equal to. And different terms will give you different types of not equal to. So inequality, the basic way that you can read this is it's like an equation. So we'll say like an equation, but not equal to. We'll do capital not equal to. So we've been dealing with equations all in Unit 2, and now we took the unit test yesterday. We're ready to move on to the actual new stuff, inequality. So everything that you've learned before in Unit 2, we are now building on top of. We're transferring our knowledge to a new system. So here are a bunch of symbols. Raise your hand if you've seen some of these before. Raise your hand if you've seen some of these symbols here before. Everyone has seen them. Okay, so let's see, quiet raised hand if you know how to read this symbol. How do I read it? If I see it and say, oh yeah, that's this. No one knows how to read it? All right, Andres, go for it.
It's going to be wrong, but is it greater than?
It is not greater than. That means it is?
Less than.
It is less than, yeah. So let's write it here, less than. Let's come back here to here. And, that's the wrong one. And then, yeah, powers have been restored. I don't know what happened there. So come back here, Andres. Why is it not alphabetical? There's your 50 XP. And there we go. Okay. Therefore, this one is a quiet raised hand. What, Monse? Greater than. Write it down. Greater than. Thank you, Monse. Let's go that direction. So there's my M for Monse. Cool. What about this one? Quiet raised hand. Cohen.
Less than or equal to.
There it is. Less than. Or it could also be equal to. Which sounds weird, right? Because these are inequalities, so not equal to, but this one says you can be equal to, so I guess our definition could have been a little bit improved. But you can be equal to as long as you have that line on the bottom. That line on the bottom is supposed to represent an equal to, and then this thing is like the greater than, so it's kind of a mix of the two. That's where it comes from. All right, and then Cohen, you got your, is the H silent? I've never asked. It's pronounced Cohen or Cohen? Okay, it's silent. New person, Fernando.
Greater than, equal to?
Greater than or equal to. Write it down. You need to know it. Thank you, Fernando. Why am I not seeing your name? That's because...
Below my name.
Wait, what? Why is this not alphabetized? Okay, I need to change the settings here. It's alphabetized by last name. Weird thing. I used to have it alphabetized by first name. And then lastly, what is this thing? Jose. Unequal, and another way of saying that is not equal to. Yep. And you guys are going to get a lot of practice today and for the rest of the unit, and I will ask you to read the inequalities. So you'll have to say 3x is less than 2x plus 5 or whatever. You'll have to be able to do that. All right, so let's just see some examples. So I'll see something like 2 is less than 3. You can do however many examples you want. You can say 5 is this symbol. 1. Does someone want to try to read this one for us? For XP, of course. Yeah, Sergio?
5 is greater than 1.
Yep, 5 is greater than 1. Thank you, Sergio. Just want to get some practice in here as much as possible. Less than or equal to, so you can say 1 is less than or equal to 1. That's true because it could be equal to, but you could also say 1 is less than or equal to 5. Greater than or equal to, so you can have 100 is greater than or equal to 0, but also 0 is greater than or equal to 0. Those are a few examples that you can see. Everything that I'm drawing or writing down here is true. I haven't drawn any false statements yet because 0 is equal to 0, so that's part of the definition. And you can say that 3 is definitely not equal to 1. There are some examples. And here is the little cutesy shortcut that I always was taught when I was taught way back when. You see how these two lines near this side are smaller? If you're on this side, because these two, and you can draw arrows right here, these two lines are smaller, they have a smaller distance between them. If the distance between these two lines is smaller, that means that this side is smaller. These two are farther apart. You can draw arrows like this. These two are farther apart, therefore anything on this side needs to be bigger. So if I'm on this side, I'm smaller. If I'm on that side, I am bigger. I always look at the distance between that symbol, distance between those lines, the ends of the lines. And if I'm being very accurate, ends of the line segments, I guess. So if nothing else, if you didn't get anything from this lesson, please just remember this 1-star rule. We're going to go through some practice problems. By the way, tonight we have 2 homework assignments, and I can just show us our unit guide that we should have updated. Here is our unit guide for this entire unit. We have a total of 6 lessons, 2 quizzes, and 1 test. Tonight we have these 2 assignments, testing solutions and plotting inequalities. So let's see how to do those. So I have this question, which values of x, what can I plug in here so that this is a true statement, so that I satisfy the following inequality? What am I allowed to plug in? And for each of these, just for example 1, and you might already see it. Wow, you guys already see it. I was just going to go through and just plug in each of these, but if you guys already see it, Andres, go for it.
It could be 1.
It could be 1. Because, so you're saying C is an answer because I can say 6, if I'm rewriting this down, 6 plus, I'm substituting, so I put parentheses, I know it seems kind of dumb because we don't really need it, is less than 8, and that turns into 7, oh, I'm getting so much lag, 7 is less than 8. Which is true, right? 7 is less than 8, so C is an answer. What's another answer? Monse. B.
D.
Oh, sorry, D. D as in dog, as in delta. Because, yeah, so if I do 6 plus that 0 that I sub in is less than 8, that eventually simplifies to 6. 6 is less than 8. Of course, if I plug in 2 and 3, those are not answers. So let's go ahead and just cross those out. You can't plug those in because if I plug in this 2, and I guess we don't really need it for this because so many people see this. But if I plug in that 2, I'm going to get 6 plus 2. 6 plus 2 is 8. 8 is not less than 8. I have to have something smaller on this side because these two are closer together. I have to have something smaller on the left-hand side. So 2 is not an answer, and 3 is definitely not an answer because then I'd have 9 on the left-hand side. So the only 2 answers are C and D. I'm choosing all the things that can apply. It's not just one of them. So the answer is C and D. Hopefully I'm beating a dead horse and you say, this is so easy, Mr. Sindel. Hopefully that's what you're thinking. If you're thinking that, then I am happy. Example 2. Try this one out. I'm going to go ahead and pause this, and I want you to do this by yourselves. And if you don't know how to do them, plug them in. For example, if I don't know how to do this one, I'm plugging 10 into A and see if it's true. So go ahead and work by yourself and then compare with people around you once you're done. All right, we're back. Help me out with this problem. Cohen, go for it.
8.
8. What about 8?
It's 4. It's divided by 2. It's 4 plus 5.
Are you saying so if I do 8 divided by 2 plus 1, then I get 4 plus 1, so I get 5 is greater than or equal to 5. So what about that? Do you want to say? It's correct. It's an answer. Yes, I agree. Thank you. Thank you, Cohen. Let's come back here. Yeah. Anything else? Fernando?
10.
What about 10?
You divide by 2. You get 5 plus plus 1 that equals 6.
So it simplifies to 6 is greater than or equal to 5. And therefore it's an answer. Yeah, I agree. What about C and D? Let's just go through the mental math really quick. You guys are going to shout stuff out all at the same time. 6 divided by 2 is 3 plus 1 is, and then yes or no is 4 greater than or equal to 5? No. Okay. So it's not C and definitely not D because that's even smaller. So correct answers are A and B. All right, very nice. Let's go to the back. So that was the first assignment that you have to do. You need to know how to check if the inequality is held true. Let's go ahead and graph the inequality. So we have another table. This is a table of important values. If you ever forget this table, I believe it is up here on the right-hand side of my cabinet. So that is how to refresh yourself. I'm about to write down a table of all of that value. So the point for this, when I'm graphing it, I don't graph a solid point. So do not do this. I don't do a solid point because I cannot be equal to that point. So I have to say everything but that point. So I do an empty point. And let's go ahead and write it on the left-hand side. And this is called open. It's like an open door. I can go through that door because it's open. I can go through that point because there's nothing there. There's nothing at that point. I can't be equal to that point. And this one also cannot be filled in because there's nothing there. Nothing actually exists at that point. I have this ghost point. I have nothing there. That is also called open. But now this less than or equal to, now I can be equal to this point, which means I have this filled in point. This filled in point, which means yes, I do exist at that value. This I call closed, like a closed door. So you can think of the point as a door, an open door or a closed door. I guess that metaphor doesn't really apply to whether or not it's equal. Maybe I should rethink that metaphor. And quiet raised hand, is this one going to be an open or closed point, Monse? It's going to be closed. Ooh, okay. So thank you, Monse. What's that next one going to be? That's a hard one. It doesn't really match any of these. Anyone want to take a guess at it? Only Andres wants to take a guess? Go for it, Andres.
Open, sir.
Why did you say open? You're correct, but why?
Because if it's not equal to, then
it matches with these, right?
yes.
Yeah, exactly. It's not equal to. These are also not equal to at the point, therefore it's open. Yeah, write it down. That's in your notes. Thank you, Andres. Good intuition. All right. And of course, we have to have a direction. We say, okay, if I'm always less than a certain number, is less than, assuming that negative is on the left, so let's go ahead and just do this on the side. We assume that negative is on the left and positive is on the right for our number line. So draw a little number line. This is an example number line in example 3. Draw a little number line. Assume negative to be on the left and assume positive to be on the right. For the rest of the year, in fact, the rest of your mathematical lives, just assume that unless someone tells you otherwise. And I'm never going to trick you and try to switch that up because that's cruel and unusual punishment, which I think is illegal. So, direction. If I'm less than a number, am I going to the left or going to the right? There it is. Left. So let's combine these two. I have an open dot that goes to the left. The example of this is an open dot with an arrow. Ooh, that's a very not straight arrow. An arrow here that comes to the left. That is the example of a less than symbol. All right, what about a greater than symbol with a quiet raised hand? A greater than symbol. I want someone new. I want someone new. Jennifer, thank you. If I'm greater than, am I going to the left or the right?
Right.
I'm going to the right. Thank you, Jennifer. So here's my example. I have an open point, and I'm going to the right. All right. I need a less than or equal to. I know I'm closed. What direction am I going? Quiet raised hand. I'm going to call on someone that I haven't called before. That means it's going to be between Eder, Josie, or Jessica. Unless one of you wants to participate. And raise your hand. All right, thank you, Jessica.
Left, right.
It's one of those two, I agree. So again, I read this as less than or equal to. Right? You have to choose one. Is it left or right? Left? Okay. Thank you, Sergio. It is left because it's less than. Less than goes with left. Greater than goes with right. And if you want a little cutesy trick, less than starts with an L. Left also starts with an L. Right and greater than, so right and greater than don't really match up, I guess. Right and greater than. They don't really match up, but less and left, they do match up with a common L. So it's left, and this one looks like this. So I'm going to the left, so I have a filled in closed point that goes to the left. That's what it looks like. All right, if I have a greater than or equal to, which direction am I going to? It's Josie. It's Josie's. It's going to the right, yeah. So I have a filled in point, a closed point, and it goes to the right. Go ahead and write down right and draw an example. That means, Eder, you're... Oh, that's cruel because it's hard. This one is unusual. I'll give you another one later, but you are eventually going to participate. All right, open. This one is hard. Does anyone want to take a guess at it? Andres is ready. Cohen's ready. Fernando's ready. I'm going to give it Fernando.
Both sides.
Both, yeah. It's left and right. We're going to say, let's say both. I like that. Both. You're going to the left and the right. It's everything. It's everything to the left, everything to the right, but not at that point, an open point. Here's your example. Not at that point, but everything to the right and everything to the left. Good guess. Yeah, good job, Fernando. Good intuition. Cohen and Andres, were you going to say the same thing? Nice. You guys have really good intuition. That's awesome. All right, so let's go ahead and do a few practice examples and we can be done with these notes. I want to graph x is greater than 1. Oh, I should have made you read this. All right. X is greater than 1. I'll make someone read number 4 and 5 and 6. X is greater than 1. So first of all, is it going to be an open or a closed point? Shout it out.
Open.
Okay. Is it going to be to the right or the left?
Right.
Say it again.
Right.
There it is. It's going to be right. So I'm going to go to 1. There it is. I'm going to do an open point. And I'm going to do a line. It's kind of hard to see, so make it nice and thick so you can see that you're actually going to the right, and do an arrow. I'm glad we can be so mature in this classroom. All right. There is my graph of x is greater than 1. And For XP, someone with a quiet raised hand, can you read this for me? Can you read this for poor old Mr. Sindel? My eyes are not so good. Eder, eventually you're going to be reading one of these, so be ready. I'm going to give it to Cohen this time.
X is there, or X is less than or equal to -3.
Perfect. You said it correctly. Good job, Cohen. You want to graph it for us also?
It's a closed circle, -3. It's going to the left.
Going to the left. There it is. Yeah, so you can say closed circle, closed point. If you say closed circle, I'm not going to be upset, but it is officially called a point. I'm just going to give you double XP. Thank you, Cohen. All right. Eder, you're up. You need to read this thing.
X equals 2.
Close. You have it. Just one little thing that you can add on to it.
Greater.
So say it one more time.
X greater than 2.
Okay, so now you're missing the other half now. So this is called greater than or equal to. So go ahead and try again.
X is greater, equal.
Greater than or equal to?
2.
There it is. Yeah, good job. All right. Thank you, Eder. And I need another quiet raised hand. What do I do for my graph? What do I do? Same people over and over again. I want to hear from maybe Jose. Yeah, Jose.
2 going to the right.
2. What type of point is it? An open or a closed point? Closed point. And you said to the right. All right, there it is. And finally, these actually don't happen on Khan Academy because they're so easy to do, but let's go ahead and graph this anyway just to get some practice in here. You will eventually need it in the future. Graph x is not equal to -1. I should have had you read it. I slipped. But who can graph that for us? Sergio?
Open point on -1.
Open point at -1.
And going both sides.
going to both sides. So going to the right, going to the left. There it is. Any questions? If you have nothing else in your notes, at least have this star. Remember the smaller and bigger, because I know there are going to be people that will struggle with this. I do care that you can say it, but at least you know which side is which. That one is smaller and that side is bigger. All right, that concludes the notes.